Section 10.1 is going to discuss quadratic equations and a different way to solve quadratic equations. Now, I already kind of hinted at this and did this in section 9.7, but we're going to use what's called the square root property. Square root property. It's something we can use to solve quadratic equations if they're in the right form. Now, what do I mean by the right form? Well, I mean that you have something like this. U squared is equal to a constant. So if this is true, then U is plus or minus a square root of k. So when you're trying to get U by itself, you can take plus or minus a square root to finish solving. The important thing to remember is that there's two possibilities here, the positive root and the negative root. But together, those are your solutions, and it makes solving these types of problems pretty nice and easy. Let's start with an example of problem number 16. W squared minus 47 equals 0. Now, if you were to try and solve this by factoring, you'd be stuck. It's hard to factor, unless you want to start using square roots. But what we can do is move the 47 to the other side, and then take plus or minus the square root of 47, and that's our answer. If you take the square root of 47 and square it, you get 47. 47 minus 47 would be 0. Likewise with the negative solution. So it's a nice quick way to solve certain types of problems. Not every type of problem is going to lend itself to solving it with the square root property, but when you can use it, it's a good tool. Let's try problem number 20. U squared minus 24 equals 0. Similar kind of thing here. I'm not sure how much work I would expect on this one. I mean, a lot of you might stop right here at U equals plus or minus the square root of 24. But there is a chance to earn an extra credit point on a problem like this. Does anyone see what that would be? Very good. So you can split this up as the square root of 4 times the square root of 6, or plus or minus 2 square roots of 6. So if you went that extra step, you'd probably get an extra credit point. If I expected that extra step, I would tell you in the problem. I'd say, all right, finish by simplifying the radical. One thing that the square root property opens up is an easier way to solve things in terms of problems like number 24. In fact, we did this very one, with different letters in section 9.7. Q squared equals negative 25. Go ahead and solve this one. I'm curious to see what you guys get. Typically, when I put a problem like this on a test, it's worth 4 points. So there's 2 points for remembering the plus and minus. The other 2 points are for getting the square root correct. What's the square root of negative 25? 5i. Good. So the I part is what's most important that I want to see when you take the square root of that number. So 2 points for the plus or minus, 2 points for the I. Let's try problem number 22. So kind of backing up a step. 5x squared minus 49 equals 0. Because there's no x term in here, we don't have 5x squared plus 3x minus 49 or something like that. Because there's no x term, I can use the square root property here. It's going to be a little bit more work though. What do you suggest I do first? Yeah, add 49 to both sides. 5x squared equals 49. X squared equals 49 divided by 5. Last but not least, take the square root on both sides. x equals plus or minus the square root of 49 over 5. Now, if you check your answer in the back of the book or on WebAssign, it's not going to match. You're going to look at it and go, wait a minute, parent lied to me. I don't get it. He taught me wrong. Well, not quite. We just didn't finish this. Let's break this up into the square root of 49 over the square root of 5. The square root of 49 simplifies. Good, 7. But we still have a square root term in the denominator. What could I do to get rid of that square root term in the denominator? Emil? Thank you. Multiply by root 5 over root 5. Plus or minus 7 square roots of 5 over square root of 25 is 5. So that's probably what you would see in the back of the book. Something like that. Let's try some more. Problem number 26. M squared plus 18 equals 0. Let me throw out another one there as well. Problem 28. 9n squared plus 121 equals 0. I'll give you a chance to work on these as I walk around, but try and solve them. Try and simplify your answers too. So when we move the 18 to the other side, it becomes negative. When a term changes sides, it also changes signs. To finish this one up, I'll take the square root on both sides, and on the right hand side I end up taking plus or minus the square root. Negative 18 can be rewritten as negative 1 and 9 and a 2. So when I simplify all this, I get plus or minus 3i square roots of 2. Now if you wrote the I after all that, that's fine as well. Any of those orders, like I said, there's 6 orders that you can use for that. Are we okay with problem number 26? Let's try problem number 28. 9n squared. When I move that over here, it becomes negative 121. Divide by 9. Take plus or minus the square root here. Maybe it's worth it just to write it like this. 121 over 9 times the square root of negative 1. This is now a nice friendly term that I can take the square root of because 121 is a perfect square. So is 9. What do I end up with? 11 over 3. Good. And times the I. So again, there's 2 important things that I want to stress here. 1, make sure you remember the plus or minus. And 2, don't forget the I. Definitely need to see both of those. That's fine too. You could do plus or minus 11i over 3. That's acceptable as well. Yeah. There's a lot of different forms that I would probably accept. What if I had a problem like number 32? X minus 1 squared equals 4. Can I use the square root property here? Yeah. Now, for a problem like this, it takes a little bit of extra care. Just a little bit. We can take the square root on both sides. Square root of x minus 1 squared equals plus or minus the square root of 4. Notice I'm only putting the plus or minus on the one side. What do I get on the left-hand side? Yeah, x minus 1 equals plus or minus 2. Now what you can't do is move the 1 over to the other side and get plus or minus 3. It'd be nice if you could do that, but you can't. You got to take just a little bit of extra time here. What I like to do is write down a positive case and a negative case. The positive case is x minus 1 equals positive 2. The negative case is x minus 1 equals negative 2. These are just 2 quick little linear equations that you need to solve. If I solve them by adding 1 to both sides, I get x equals 3 or x equals negative 1. So, like I said, what you can't do is you can't just kind of cheat, move that over to the other side, and combine like terms and get plus or minus 3. It doesn't quite work that way. But if you're a little bit more cautious, then you can get the right answers without too much fuss. Let's try problem number 34 as a good follow-up to that one. And instead of the s that they use, let's write an x. X minus 7 squared equals 9. See if you can't come up with the correct 2 solutions on that one. Square root of 9 is 3. And basically it's asking you, did you take the time to write down both possibilities? What answers did you get? Good. 10 and 4. If you weren't sure about your answers, how could you check them? Yeah, plug it back in. Let's check the 4. 4 minus 7 is negative 3, but when I square negative 3, I get 9. Same with 10 minus 7. Gives you 3 squared is still positive 9. Let's try one a little bit harder, and I think this should wrap it up for that part of things. We're going to have to work on something called completing the square here. So problem 72, 5x minus 2 squared equals 64. First step. Anyone? Take the square root on both sides. So square root of 5x minus 2 squared equals plus or minus the square root of 64. When I take the square root on the left-hand side, I get 5x minus 2 is plus or minus 8. You still got to do that positive and negative case stuff. So let's take care of that. 5x minus 2 equals 8. 5x minus 2 equals negative 8. What two solutions are you getting? I get 2 and negative 6/5 as my solutions. Again, you can check these. If you were to put it into the original equation, 5 times that, the 5 is going to cancel. Negative 6 minus 2 is negative 8. Negative 8 squared is 64. So it checks.
Whenever we have a problem that looks like that, 5x minus 2 squared, do we always have to check do the add and the subtraction, the bottom?
Yeah, because what happens if you try and move the 2 over and do 5x equals plus or minus 10, x equals plus or minus 2, well, one of those solutions is wrong. It would be the negative 2. So,
Also, whenever there's like something attached to the...
yeah, whenever you have this plus or minus like that, really, if I was being very, very formal about this, when you took the square root, I'd make you write out, these two cases. I wouldn't let you use the plus or minus. The plus or minus is just a convenience for us, but it really does mean this. So, yeah, unfortunately, you can't just move the 2 to the other side and solve. Now, we're lucky in a lot of these problems that we already started out with something squared. We start out with a binomial squared. Like, oh, when I square this, I've got this. That's not always the case. So sometimes we kind of want to engineer that to happen. And what I want us to look at is a process called completing the square. Completing the square. And let's examine it with this example. X plus 5 squared. So we're starting out with this binomial. We're going to square it. That's going to be x plus 5 times x plus 5, which is x squared plus 5x plus 5x plus 25. We're better yet, x squared plus 10x plus 25. Now, in this part of the homework, here's what you're going to be doing. They're going to start you out with part of this polynomial. They're going to start you out with x squared plus 10x. We're going to need to figure out what we put here so that when we put that number here, I get this perfect square. I get x plus 5 squared. So how are we going to do that? How are we going to figure out that g, the number I need here, is 25? Well, let's think about where that 25 came from. In this problem here, where did the 25 come from? What did I do to get the 25? I did 5 times 5. I squared the 5, right? Now, if you're just looking at part of this, if you're looking at this and saying, well, how am I going to come up with a 5 by looking at this, what would you do? Yeah, multiply by a half, divide by 2. All right, you're going to take this number, divide it by 2, so 1/2 times 10 is 5, and then 5 squared gives you your 25. So it's 2 steps in coming up with a number that completes the square, is what it's called. And I'll write that down for you in kind of nice general terms, if you give me just a second here. So to complete the square, you're going to follow this process. So to complete the square, I'm going to do that on x squared plus bx plus something, and that'll give me a something squared here. So I'm trying to give you the general format of this. The first step you're going to do is what Norman said, and that is multiply this by 1/2. So multiply by 1/2. So 1/2 times b. 1/2 times that middle coefficient. The second thing is you're going to square this result. So square the result from 1. Square the above result. So you're going to get 1/2 of b squared. You could also think of this as dividing by 2. There is a little bit of a convenience to think of it as multiplying by 1/2, but either way works. Now, the 1/2 b squared term is going to go right here. So that's going to help you fill in this. And then this part actually helps you fill in this. So let's take a look at a couple examples like this. We'll start it with problem number 42. So problem 42 is b squared plus, no, is it 16b? That's 11b, isn't it? No, I'm going to change it. This is going to be problem 42-ish. B squared plus 16b. Now, if I want to complete the square on this, then it's going to be 2 steps. The first step is to multiply the middle coefficient by 1/2. So 1/2 times 16 is what? 8. Then take the 8 and square it and get 64. That 64 is going to go right here. The 8 helps us out as well. The 8 helps us out with the factoring. If I was to factor b squared plus 16b plus 64, how would that factor? B plus 8 times b plus 8. And from the beginning of the course, I asked you to write something like that as something squared. So b plus 8 squared. So you've turned this into a perfect square trinomial. Let's back up a step and do problem number 40. If there's something about problem 42 that you're unsure of, though, here's a good chance to get some help. Okay, so let's try problem number 40 then. Y squared minus 18y plus something is something squared. This is exactly the way I would write it on a test. I'd say complete the square and give you it just like we see here. So see if you can't do that. Work with that middle coefficient, square it, figure out how this thing factors. I'd ask who I haven't picked on in a while, but I never get any volunteers on that one anyway. So, Lauren, let me pick on you. 1/2 of what? What's that give me? And when I square -9, ooh, positive 81. Yeah, positive 81. So that 81, where does that go? Goes right here. So 18, just give me y squared minus 18y plus 81. How about in the parentheses? What's going to go in the parentheses? Y minus 9. Good. Now, sometimes people will just write -9. But if you square -9, am I going to get the rest of this stuff? I'll get the 81, but I don't get the rest of this stuff. So make sure you put in y minus 9. Okay, so let's go back and do, you know what, before we do that, put your pencils down for just a second. Let me show you, and just kind of take a break here, why people use completing the square. I mean, part of why. It's a way to solve quadratic equations, and you can do that for problems like number 48. Now, as usual, I'm going to make this 48-ish. All right, just so that the numbers work out a little bit better. Let's do x squared minus 6x plus, do plus 5 equals 0. Now, typically on a test, you'd probably factor this and solve this. But you could also do this by completing the square. X squared minus 6x equals -5. So I just move that to the other side. Let's complete the square on this term here. So the process for that is to take this and multiply it by 1/2. Half of -6 is -3. -3 squared is 9. So what if I added 9 to both sides? Plus 9 here and plus 9 here. The left-hand side is a perfect square. It's x minus 3 squared. The right-hand side is a 4. Okay. Now what can I use to solve this? Square root property. So square root of x minus 3 squared equals plus or minus square root of 4. X minus 3 equals plus or minus 2. So there's two possibilities. X minus 3 is 2, or x minus 3 is -2. And I get solutions of 5 or 1. So that's the process of solving this by completing the squares. Now sometimes you kind of have to do something like this or something different because your problems won't factor. But let me tell you, on your exam, I'm just going to say solve. I'm not going to say factor, square root property, quadratic formula, completing the square. I'm just going to say solve. We solve this one by completing the square. But if you're given the choice, would you complete the square or maybe something else like factoring? Oops, this doesn't factor like that. It factors x minus 5, x minus 1. So, all right, helps if I can factor. X minus 5, x minus 1. We get two solutions, 5 or 1. Which one are you going to choose, factoring or completing the square? I hope you choose factoring. I mean, I've seen people solve like an entire test worth of problems by completing the square. But boy, you're going to be really working hard to do it that way. I will not make you solve a quadratic equation by completing the square. But you are required to know this process. This is what I want you to know. And it's not just for working with quadratic equations. It's later on when we start working with circles and ellipses and hyperbolas that you need to know this process. So it's sowing the seeds for something that we're going to see later on. All right. I'm getting all these forlorn looks. We will get out early. Trust me. We still got like 25 minutes left, though. So, all right. Gosh, I feel like everyone's staring at me. Uh, well, uh, let's finish up with problems 42 the real way and problems 44. So, a couple quick ones. So, the real problem 42, earlier we did problem 42-ish. The real problem 42 looks like this. B squared plus 11b plus blank something squared. Now, when that middle coefficient was an even number, this wasn't such a problem. But now that it's an odd number, it's a little bit more challenging, but it's not that much different. The first step, and Norman carefully explained this to us, was to multiply the middle coefficient by 1/2. 1/2 times 11. So I can think of that as 1/2 times 11 over 1, or better yet, I'll get 11 over 2. So what you should get when you multiply 1/2 times 11. What do I get when I square 11 over 2? 121 over 4. Just leave it as fractions. We don't have to convert it to decimals. See if you can't use those two numbers, now that I've helped you create them, to help finish off the factorization in problem 42. We got the hard part done. Let's finish it up. Okay, so Kyle, what goes where? How do I fill in this stuff? All right, so this one goes here, plus 121 over 4. Good. What goes in the parentheses? Thank you. B plus 11 over 2. By the way, this sign and this sign should always match. So that one's always going to be positive. These two are always going to match. So if I had a minus here, I'd have a minus here. Plus and a plus. But it's the same two steps. It just wasn't as convenient because this wasn't a nice even number. Problem 44. X squared plus 2/5 x I would suggest that you simplify when you multiply the 1/2 times that middle coefficient. Simplify that fraction. Well, there's two things. One, you don't add these. You multiply. It should be 2 over 10. Yeah. Another thing, I would just cancel the 2 there. Just put it that way. This is a suggestion. So the half of this of 2/5. Personally, I would suggest that as you're multiplying these two together, that if there's any simplification, you do it. The 2's cancel each other out, so I get 1/5. 1/5 squared, 1/5 times 1/5 is 1/25. That goes here, 1/25. The 1/5 comes over here to help us factor it. I get x plus 1/5. So that's it. Nice. Let me give you some homework. This is section 10.1. 15 through 29, 39 through 45. Let's see, 71, 77, 83, and 95. Have a great holiday weekend. See ya!